To start any motherboard, there should be two major master chip requirement has to be fulfilled. Those are, one is IO and other one is PCH. These two IC requirements, the basic requirements has to be fulfilled. It means in IO what we have seen, one is PSID, next power switch in, lead switch, it's a ground, EC ground, it's a crystal, this one AC disk, so on, see I adapter, I bat, AC in, power select, P bat present, SMB data, SMB clock, RTC section, 3 volts always main supplies, 1.8 volts always EC and 1.0 volts. These are the major basic requirements to the IO before pressing the power button, right? Similarly, the PCH requirements, what are those? 1.8 volts prime, 1.0 volts prime, 3 volts always underscore PCH, 3.3 volts always DSW, 1.8 volts prime and RTC section. These are the main basic requirements of the PCH, right? So after these two smart IC, one more smart IC requirement also you must check before pressing the power button. That is the most important thing, that is SPI ROM. See, UC3 is the SPI ROM, that's called BIOS. So let us discuss about the BIOS, how it will communicate before pressing the power button and how much it is very important. Already I explained multiple times, PCH has multiple blocks. In that the major blocks are, one is SPI block and LPC block. These two blocks are related to the BIOS. Okay. See here IO, actually I cut and paste from the top portion. Here is the IO. IO will communicate with the PCH. How? These all basic requirements once it's okay. See now the IO, the embedded controller chip, how it will communicate with the PCH? See, the pin number is 57 to 62. These signals, that is ESPI underscore clock, ESPI underscore CS hash, ESPI underscore IO0 to IO3. These are the major signals. Through this signal only the IO will communicate with the PCH regarding the BIOS. It means EC BIOS will enter to the CPU. I mean it's a PCH SOC. Okay. Next, one more important main BIOS is SPI. This also should be okay before pressing the power button. Otherwise, after pressing the power button, this smart chip won't work properly. So your ampere may increase up to 0.025. It may get stuck there itself, or it may be 0.125 like that. Okay, it will get stuck. It won't work properly. So to work properly, this BIOS also should be perfect. See, as we know, here it is a 3.3 volts always PCH. This one will convert as a 3.3 volts underscore SPI. Through this signal only, the BIOS chip will get active. Okay, the main supply will come from this particular signal. Means voltage. Once it enters, these are the pin. As per this pin, 1 or 2 signals will enter to the TPM device. At present, in this particular motherboard, it doesn't have. So you are getting TPM error, right? Because of this only. In case this TPM device is faulty, or some of the program has got corrupted in main BIOS chip, then you will get this kind of error. Okay, TPM device error. Usually in Dell Latitude and commercial series we can check. You are able to see those things. So now see, this is UC3. Okay, from this UC3, these are the signal the PCH will receive. It will communicate through these signals. One is PCH underscore SPI underscore CS hash 0. Like that, PCH underscore SPI underscore D0, 1, 2 and 3 and SPI underscore clock. Okay, these are the most important signals to communicate between PCH to BIOS chip, and here through that LPC block the IO will communicate. This is the BIOS communication. Okay, through SPI block the main BIOS chip will communicate. Actually it's a SPI flash chip. Okay, that chip will communicate, and IO, the embedded control, will communicate through this LPC block. Okay, this is the most important thing in BIOS, in motherboard S5 state. Okay, so we will discuss more related to the S5 state voltages in next videos. Till the time, thank you very much.